Is the best way to do it is to actually replicate what happens on the sun.
The principle is quite simple. When you have two atoms of hydrogen, if you make them collide, they will fuse.
When doing so, they liberate a huge amount of energy. The energy we will then use to actually produce electricity. It sounds simple because stars have been burning on fusion for billions of years.
It's the fundamental energy of the universe.
But we need to control it on Earth.
Here we are, it's ITER.
ITER is a large international program in order to demonstrate the feasibility of fusion technologies.
Probably one of the biggest scientific and technological challenges that human race had to face.
In the sun, the pressure is very high.
To get that same kind of collision of nuclei, we need really high temperatures.
150 million degrees in ITER.
It's quite hot.
Probably going to be the hottest point in the universe right here in Cadarache.
You can't really make the same scale of the sun on Earth. We have to use a special device called a tokamak, which is basically like a donor.
So we are now constructing the whole platform and then starting to construct the machine itself before we can actually use it.
Here you'll have the tokamak.
The plasma is the state of the hydrogen when you heat them and you produce fusion power.
So you can think of a plasma as a ring of lightning, if you wish, which is traveling around the machine, held indexed by strong magnets.
There is many challenging technology to have to be assembled and working all together, and it is a challenge we have to face.
So where I stand, there will be the vacuum vessel, and attached to the vacuum vessel, you will have 440 modules of the blanket covering all the vacuum vessel and facing the plasma, and roughly about 600 meters square in area.
Basically, the main fuel source will be seawater.
This huge machine is fueled by this tiny part.
We are now making things which have never been done before.
Just to give you an idea, these neutrons have so much energy, there was nothing to stop them. If it was in space, it would travel from here to the moon in 8 seconds.
There is, I would say, a miracle around ITER.
It's always shown that the planet is able to collaborate on a scale somewhat above the normal argument level.
It's more than 30,000 people all over the world working in order to deliver and manufacture the different components.
Obviously, it's quite a challenge to keep the plasma contained inside a tokamak. So to do that, we need some super strong superconducting magnets.
This is the superconducting cable to be wound in a circle shape.
It's the largest magnets that have ever been manufactured in the world.
You need these very large magnetic cages in order to maintain this 150 million degrees plasma away from the wall.
The magnets are super cooled because they have to be really strong. They're one of the coldest things in the universe.
So in 10 meters, you go from near the absolute zero to 150 million degrees. I can't imagine anywhere in space where you can find this kind of gradient.
As a scientist, I have been looking for this technology for several decades.
Everybody knows what they're doing, they're just going to get on and do it.
If we succeed, it will be a real breakthrough for the energy supply for the world, not just a century, but millions of years.
We really need to work on this as soon as possible and prove this as soon as possible.
The future energy issue will be on our shoulders.
We don't then prove that fusion is a possibility.